Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video demonstrates how to use the conventions for hypothesis testing of two population proportions to solve an example problem. Let's get started. So the example problem we're going to look at involves this old wives' tale about Echinacea. And in fact, I remember I had a friend in college who swore, okay, she learned this from her mother, and so whenever any of us got sick, okay, she would she would go to the store and she would buy Echinacea and give it to us. She's like, I swear this is going to work. This is going to help you fight the common cold, to help you get better sooner. And, whether or not that's true, well, let's look at a statistical study where they actually examine that question. So we've got 45 subjects who were treated with Echinacea, and of those 45, 40 developed a common cold infection. And then there were 103 subjects given a placebo, so they just got a sugar pill. And, well, it must have been a green sugar pill, because all the Echinaceas that I've seen, it's just, this ground up. Well, it's green, so, it's got to look green. So, green sugar pill. Well, I don't know. It's kind of like a green M&M, only without the chocolate taste. Anywho, 103 subjects developed and got the placebo, and of those, 88 developed the cold infection. So, notice we've got the same standard 5 questions that we've always been asked about these hypothesis test questions. And the claim that we're going to look at with these 5 standard questions is that Echinacea has an effect on developing a common cold infection. So the first thing we're going to do, as always, is go and look and see what are our null and alternative hypotheses. And to do that, the first thing we do is think about what is the claim. Well, here the claim is that Echinacea is effective in treating colds. So that means the proportion of those who develop colds in the Echinacea group is going to be less than the proportion of those who develop the cold in the placebo group. So P1 is going to be less than P2, or you can write it as the algebraic equivalent, which you see in StatCrunch. P1 minus P2 is less than 0. As always, the null hypothesis is a statement of equality. So notice we take our population parameters and we just write them out as we did with the claim, but now we're going to set it equal to 0. The alternative hypothesis typically reflects the claim, provided there's no semblance of equality in the claim. So look at the claim, and there is no semblance of equality there, so we can just adopt that as our alternative hypothesis. So notice that we're going to have a one-tailed test on the left, because that inequality sign there is like an arrow pointing to the left. So we have a one-tailed test on the left. The value of the test statistic we can get by using that monstrous equation that we saw in the previous mini lecture, or if we want to join the 21st century, we'll use StatCrunch. So in StatCrunch, go to Stat, Proportion Stats, because we're dealing with proportions, to Sample, because we've got 2 samples we're comparing, and we want to choose with Summary because we don't have any actual data, just summary stats. In the options window that appears, notice we've got the part and the whole for 2 different samples. And typically, the one that's mentioned first in the problem statement is going to be sample 1. So if you notice from the problem statement, the Echinacea group was mentioned first. So those numbers for the Echinacea group are going first here into sample 1. And then sample 2 is the placebo group, so those numbers go in second. Notice we've got the same fields here for our hypothesis test, only this time typically you're going to leave this default value of 0 as is, and all you're going to do is adjust the inequality sign here with the alternative hypothesis. So once you've got that, go ahead and press compute, and then read what you're looking for right off the results window. So you've got the test statistic, which is, as always, the second to last value there in the results table. The p-value, as always, is going to be the last value that's there in the results table. Just read it right off the table there. Are we going to reject or fail to reject the null hypothesis? Well, we're going to use the same criteria that we used previously. So if we're inside the region of rejection, we're going to reject H0. If we're outside the region of rejection, we fail to reject H0. So go back in and looking at our results that we saw earlier. We look at our p-value. That p-value of 57.2% is definitely greater than 5%. So we're outside the region of rejection, and therefore we fail to reject the null hypothesis. Alternatively, we could use the test statistic if we wanted, the 0.56. That puts us right about here. And you can see our one-tail test on the left, that's where our critical region is. So we're definitely outside the region of rejection. We reach the same conclusion, fail to reject the null hypothesis. Again, there's our critical value, and there's our test statistic. What do we conclude from the hypothesis test? Well, that same pattern that we learned when dealing with hypothesis testing for one sample is going to apply when dealing with hypothesis testing for two samples. So, did we reject the null hypothesis or fail to reject the null hypothesis? We failed to reject the null hypothesis, and therefore we're going to say there is not sufficient evidence. So looking at answer options A and B. And then to decide which one of those we pick, we remember that we had a one-tail test and not a two-tail test. We had a one-tail test. And so we're going to say support the claim. If we had a two-tail test, we would say warrant rejection, but we don't. We have a one-tail test, and so we're going to say support the claim. That leads us to answer option B. Again, notice where the different parts come from. We failed to reject H0, so that means there is not sufficient evidence. We have a one-tail test, so that means we support the claim, and then the rest of the statement is just rehashing the claim itself. And that's really all there is to it. So a lot of the procedure that we have is exactly the same. So there's not a whole lot of new things to learn. There's just a little bit of adjustment that you got to make because you've got two samples you're working with instead of just one. And that brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.